Welcome to my channel. For this video, we're going to share an analysis for problem 105, construct binary tree from preorder and inorder traversal. So for this problem, we're going to provide a recursion solution. So first, I'll read through the statement of the problem, and then we emphasize some of the constraints, and then we analyze the idea and write the code. So first, let's look at the statement of the problem. So given two integer arrays, preorder and inorder. So where preorder is the preorder traversal of a binary tree, and inorder is the inorder traversal of the same tree. So we are required to construct and return the binary tree. So the return is the root node. So let's look at one example to gain some intuition. So this is the binary tree structure, and this is the preorder traversal, and this is the inorder traversal. So this is the output. So this is just a format of representation. So here I want to emphasize some constraints. So the second constraint says that the inorder list and the preorder list have equal length. This is going to be important for our solution. Another one is that the preorder and inorder consist of unique values. This is also going to be important for our solution. So the last three items basically tell that the inorder and the preorder are the same tree traversal result. So with that said, let's look at the method. So here the method we are going to use is a recursion method. So by identifying the root, the left subtree, and the right subtree. So let's look at example 1. So here is the preorder and inorder lists. So I'll start from the preorder list. By the definition of preorder list traversal, we first look at the root, and then we traverse the left subtree, and then right subtree. So therefore, the first element in the preorder list is nothing but the root value. So this is a crucial information. So here the root value is 3. So with that information gained, we can look at the inorder list. So due to the assumption that the values of the nodes are unique, so we know that we can retrieve the index of this root value 3 from the inorder list. So here is the 3, the root value. The index is 1. Then we are going to use the definition of inorder traversal. So we know that for inorder traversal, we first traverse the left subtree, then we traverse the root, and then we traverse the right subtree. Therefore, in the inorder list, left to the index or to the value 3, it's the traversal result for the left subtree, and right to the index 1 or to the value 3 in the inorder list, so it's the traversal result of the right subtree. So with that said, actually this vertical line partitions the preorder and inorder traversal list into 2 parts respectively. Then it provides our foundations to do recursion. So with that said, let me share the code and emphasize some points. So I guess in some sense the code is itself speaks louder than the analysis above, but the analysis helps understand the definitions of preorder and inorder traversal better. So let's look at the code. For the code, I'm going to first make some special case. So if not preorder, I'm going to return null or nothing. So from the constraint, we know the preorder and the inorder are not empty. So some may suspect why we need this one. I'm going to come back to this point later. So this if check is crucial for our solution. So with that said, I'm going to first track the root value. So this is from the preorder list. Preorder list. The first element is nothing but the root value. And then I'm going to track the index information of this root value from the inorder list. So inorder. So we want to track the index of this root value. So once we've done this, so we are ready to construct the root node. So the root is a tree node. So this is the class definition and initializer. So the tree node. So the value is going to be the root value. So with that finished, we're ready to set the left subtree and right subtree of the root. So in order to set the left subtree, I'm going to make a recursion call for this function itself, and then we want to find the proper preorder and the inorder traversal. So for the preorder, so it starts from index 1 and ending at this index, the IDX. So starting from index 1 to exclude the root value, and then ending at this index, so we write it IDX plus 1. And the inorder list, so it starts from 0, so I just write it specifically for emphasizing this point, and ending before the IDX, the index 1, so I will write IDX here. So this is the one. And then similarly we can set the root right. So again it's a recursive call. And for the preorder, so it's going to start from this index up to the end, that is IDX plus 1 to the end. And for the inorder, it's also from IDX plus 1 to the end. So once these two subtrees are set, so we are ready to return the root. So that's the whole code. So let's do a special case check. It passes the special case, and then let's do a generic case check. Yeah, it passes the generic case. So now let's come back to this part, to this if condition. So this if condition is crucial in the sense that this plays also a role of terminator. So for example, if we examine a leaf node, so it has no left or right child, the corresponding input for this preorder list and the inorder list are actually empty lists. So we need to stop when we see a leaf node. That's the role of this if check in this recursion function. So with that explained, I guess that's about it for this problem. So you're welcome to check out other videos in my channel. Thank you very much.